Mo
How do you know?
Okay, so
you driven that car?
Yeah, today.
you're still alive? Oh man, this is a really wide screen. Okay, so just giving you some background there. I'm doing Python, and I have a manufacturing project that I've been working on for a long time, and there was a really good opportunity to be able to write some flow control. So instead of like, I have a list and I go to a set and I go to another thing, then another thing, then another thing, I was like, I just kind of want to go from here to here and get the stuff out. And there's really no good tools for that in Python right now. And someone could say that there's a Py functional library, which is kind of similar, but this is better, so don't bother looking it up. And so, just starting off.
Could you make that a little bigger?
Maybe.
Yeah.
Is that bigger?
That's big.
Okay. What's this? There it is. Okay, so. Okay. Where's my super easy, simple example? So this thing here is first example here of we have some really great data. You might recognize 1, 2, 3 from somewhere. And so this here strings a absolute value method to all these things, so everything goes to positive, and then it goes and reduces it to the maximum value. So you have this pipe object here, which basically all your methods are attached to. And absolute value is a built-in method. So I've just been able to take all the built-in functions and a few other packages that are native to Python and put them into this because there's really easy add-in features, which is another thing that I've been trying to do. So that's our super simple example. And so then there's another case where reusable pipes, and I came up with this one because I had a pipe in a really nested area of for loops, and the only other piping library that I had available was one that had to rebuild the pipe every single time. And so this one here keeps your pipe open so you can reload it with new data and then pass it through. So like we have this data here, which is really not anything spectacular, but example data. And we create a pipe with empty, so it's not preloaded, so there's no data preloaded into the pipe, like the first example here where we put the data in directly. And so then we have this map function, which you might, is anyone like familiar with Python here? Okay, so you know how in map things aren't really split up too well? So like if you have multiple intervals, it kind of zips it together, but this one here will split your tuples automatically. And that was kind of annoying me with a lot of the other lambdas and map functions previously. So there's a wrapper that goes in there and it takes it apart if your lambda function that you pass in has more than one argument. So you can do a single argument here still, and then it would just pass in this whole tuple here. But then another just thing to make more data. So it does 20 times A, then 8 times B. And then we filter this to where the 8 times, well, it should be 20, but 8 times 2 is greater than 8B. And then we can pass it into a list. And so then when we go through our while loop, we want to make sure, everyone knows beta, so that's good. But we can call this pipe multiple times without rebuilding it and having all that overhead in there. And so the data will be then modified and passed back into itself. And then you could do that as many times as you want and then get some result based on the end condition that you're looking for, which is basically the length of data it's greater than 2. And so then there's also extendable pipes. So extendable, I mean like you can have a pipe object, but then you can add more methods to that pipe object and still be able to use the original and the extended pipe. So if you want to run something through this one, but they also want to have added methods to the next one, you're able to do that. So what here, this first letter is basically just creating the uppercase of the first letter here. And then the all letters just uppercases all of them, so it puts them all in upper. And then this tuple here just puts it to a tuple, which is kind of like an array if you're not familiar with them. And so then these pipes can also be used as iterators. So like here, where we pass in this data to first letter, it will then be able to call the next method on this and pass that into words. So you can actually use them in other for loops. Seems like you probably want to just extend the pipe further, but that's the case of that. And then you can reuse that, use that next pipe, which uses everything in our first pipe and then puts it through these next methods too. And so now here's the best part of it, in my opinion, because it's really, really easy to add methods to the pipe. Any questions so far? Is everyone up to speed? Anyone not understand besides you?
I cheated, I already looked at this website.
You did? That's fine.
Okay. Let's get,
When? Yesterday? Or today?
yesterday.
Oh, well, that's new.
Oh.
News since this morning. Okay.
Was it this morning that I looked at it?
Oh, well, sometime.
It was on my calendar and I put it down yesterday.
Okay, Victor.
Anyways,
Link was.
so if we wanted to implement these methods here, which I had to call our screen so we can see both of them at the same time, but this next example re-implements all these things, but we add this upper method, and we also add like the first upper method. And so you don't have to use all these lambda functions here. You can just call those methods directly as a method on the pipe.
So does that modify the global class object? So if you add a method somewhere and then somewhere else someone adds a method of the same name, those are going to clash?
Yeah.
Does it raise an error if you try and overwrite an existing
Yeah.
method, or does it? Okay.
Yeah. So it has it gives you the capability of overwriting, but it does raise an error if you do try to overwrite. So yeah, so you have the capability of overwriting, but you don't. If you don't say that you explicitly want to, it won't do that. So this is the simplest way. You just do, and this is adding a map method. So this will be applied to every element that goes through that segment of the pipe. So like the string.upper is going to add the uppercase method of the string. It's taking the string method upper and adding it to the pipe. So if you call upper, like right here, that is now part of it after we added it. And you can also add lambdas and specify their own names. There's a lot more options, but I didn't include them in this example here. So then if you want to do exactly what you're doing, what was up here, these parts are a lot more readable, which are now just these parts here. So I think that's pretty useful in a lot of cases, instead of having to do map lambda everything. Is that computing with everyone? Got it? All right. And so another really interesting thing that I added to this was, in a lot of the other libraries, if you have a key, like if you have a key value pair, basically if you want to keep that key, you have to keep on passing it to the next one, and you manually have to do that. And I was getting really tired of that, so I created these like carry key and rekey methods, where the key is broken off and it only passes the value through this method. Is it too small?
Oh, that's fine.
Okay, yeah. So the key is broken off, and then the value, which is like the age, the 5, the 9, the 12, and the 2, are then passed through the add and then the filter method, and then they're rekeyed with the proper key. So if we do this result here, we'd end up with Billy and Kate as our results, but the value would be 10 and 13. So I think that's really good. And you can also do this with dictionaries with a specific key for that dictionary. So like carry dict will now carry It's going to be passing the age through this object here, and it's going to carry the rest of these dictionary values, which is just the name at this point, but you can have as many as you want there. And then once you do the return dict, it will reset this age value to whatever is returned.
Sorry, what is add one doing there before the field?
Oh yeah. So this is just the add method, and this is adding one to the age or the integer here.
Okay.
So this add one's a method. Okay, we can.
So you increment the age because you did carry key before?
Yeah. So the carry key. All right. Let's go into this. So carry key splits it here. So this thing here, this John is no longer going through this add and filter method. And it's only passing this age integer through these two methods, but then we rekey it. So it's like carrying the key from this point to this point.
It's just assume the second part of the tuple is value and the first part is the key.
Yeah.
If you pass in a dict, is it gonna also?
So this is what this dict here, it doesn't, so you can sort of do that, but it's not going to work unless your keys are specifically designed for that. But the dict method is the carry dict, and this one here is going to carry the dictionary and pass the H through. So each of these things are like a mapping or dictionary with name set to John and age set to 5. So once we get to here, John, the dictionary is kind of set on, it's not modified anymore, and this age, just the 5, is passed to the add and filter method.
So what I meant was if data itself was a dict instead of a tuple.
Yeah, you gotta be careful with your types on that.
So pipe only takes in tuples and lists. It doesn't.
No, it'll take any data in. It's just, if you want to use these things specifically.
It'll only work if it won't work if you pass in a dict. It'll only work if you pass in.
Yeah, so if like you try to use this carry key when the elements being, if you try to use this carry key here with this data here, it's not going to work because it's expecting it to be a tuple like 2.
Yeah, I'm curious, you more deeply invented the dot filter. I know it's Python.
Yeah, because that's part of this carry key. So in all reality, the syntax hasn't been completely worked out yet, but in my own mind, I was thinking I would indent this because right here, this carry key and rekey are basically going to be connecting back to each other, right? And
Okay,
then,
I get it.
and then this filter here is getting only parts of the.
It's getting the age.
Yeah, it's just getting the age
Yeah,
to
okay.
it.
So you called the one instance rekey and the other one you called return.
Yeah, it's still a work
Okay.
process. We can, if you have any suggestions for the names, I'm all
There's intended to
ears.
be some symmetry of some sort.
Yeah,
Okay.
I'm working on that one because I didn't like rekey too much. I didn't like return date too much either. But that's what I thought of at the moment. So if you have better ideas, I'm all ears for that. Anything else? Oh, okay. And so those are the main methods there. Your imports here, basically you just say functional pipes, pipe, and then you can load in the specific packages that you want. There's really no methods built into this pipe object. So just to keep it leaner, and you have to load whatever methods you want. And I'm still working on the documentation for all the methods, but basically these are all the built-in methods of Python. And then these are the other built-in map methods. But then there's some custom methods here, which allow you to zip internal things. But I don't really want to go into those too much. But the main point is for these pipes, you're able to add methods, you're able to add map methods very easily. You can also add, what is it? You're also able to add your own custom carries like this too. There's an implementation method that allows you to define them in a dictionary with its own specific features, and that will allow you to make any custom carry you want. And that's basically it for now. So suggestions I'm very appreciative of because it's new and
I had a question. You go pipe, then a dot method, dot method, dot method. What term do you use to refer to that? Is it chaining, cascading?
oh, these are chaining.
You call it chaining?
Yeah, well, basically it's chaining the pipe object together, but it's not actually your pipe's being assembled really. So this is the chaining to assemble the pipe. So I haven't come up with any specific terminology for that. I'm sure there is, but I haven't looked it up.
Yeah, I think there is. I want to say it's called a fluid interface.
Yeah.
That's right. That's the term that I've heard.
Okay, fluid interface.
Yeah, fluid interface.
Okay, I'll look that up. It's a fluid interface.
So question,
So,
are you using in production somewhere?
yeah.
Right, okay, thanks.
So in terms of like if you have lists that are like extremely large data sets, like ones that are really large, I think you might have mentioned this when we were sitting here, but you're not calculating like the intermediate values, right? Like you're not storing, like, there isn't like if I have a list that's going to a billion things, like going through every stage of the pipeline, it's not trying to calculate like.
No. So it's basically everything draws from the next one up, right? So if you ask it for something, it'll go to your data set, grab one thing, and then pull that through, and then it'll go through to the next one and pull it through.
Okay.
Yeah, so it's not at every stage. So like this one here, it's not adding one to every single one, and then putting that through the filter, and then putting it through the read key.
Right. Okay.
And then the tuple. There are some methods that do require that, like sort methods require you to load everything. But for the most part, if it's doesn't need to have everything loaded through it, it won't do that.
Okay. So you can use it on like if you have like a continuous stream.
Yeah, if you have a continuous stream of work.
Generate infinite generators? That was the question.
Yeah, if you had an infinite generator, it would work. As long as you don't use the methods that require you
To do the whole, yeah.
to do the whole thing.
Is there a reduce method since Python removed their reduce?
Actually, Python didn't remove their reduce. They put it in the, I think it's function tools or iter tools.
Okay.
I think it's iter
reduce
tools.
on here.
Or is it function tools? Okay, one of the two. Yeah, so there's, I have to check that. I'm not sure if that's been added yet. I can put that in. It'd be super easy to add reduce in this.
You added flatten. I didn't see that anywhere.
Flatten's in there.
Okay.
Yeah, flatten's built in. Yeah, I just added that yesterday because I needed it. But yeah, flatten's in there.
Of all the things Python really.
Yeah, well, yeah, flatten is definitely in there because I was like, I need this, so put it
Did you
in.
write an email to Guido?
Yeah, I don't
Because that killed me.
I don't think that's going to work. There's definitely flat methods written, so if you want a flat method, just go grab it from a package. But yeah, it's not built in. Sorry.
I had another question. This may even go beyond Python, but I mentioned the terms chaining and cascading and fluid came out. I'm wondering, is that dot notation? Could you also consider it function composition?
It really sort of is, but it's more of like an iterator composition. Yeah, because in all reality, it's not trying to pass one thing through it. It's trying to be able to make something where you can pass lots of things through it.
So when you're in a language that doesn't have dot notation for doing methods, you can use a compose function to get a very similar functionality, but compose is kind of a more generic and even more powerful version of it.
It's a question or?
That's
No, that's an answer.
Okay.
suggestions, please? None? Okay. Thank you. Let's make a 5-minute break. Just, the restroom is in the gym, just there at the side on the left. And yeah, 5 minutes and then we go back to yours, the next one.
Yeah.
Next?
Yeah.
Oh, okay. The reason I asked is I was watching